What is Ohm's law? In this lecture, I will teach you something very special about Ohm's law, which a lot of people are neither teaching nor understanding. So watch this lecture till the end. Firstly, let me teach you one real-life example. Consider a ball at a certain height above the ground. When we release this ball, it accelerates towards the ground. Now here is one important question. Why the ball accelerates towards the ground? Well, the answer is simple. We all know that at this height, the ball possesses high potential energy. Let it be 30 joule energy. While at the ground, the ball possesses low potential energy. Let it be 1 joule energy. We say that the potential difference between this region and this region is 29 joule. Thus, it is the potential difference due to which this ball moves towards the ground. Remember that when this ball moves from high potential region to low potential region, it experiences air resistance. I mean, air resists the motion of the ball in opposite direction. Therefore, it is universal fact that in gravitational field, objects move from high potential region to low potential region in order to lower their energy. Similarly, consider this electric field. Let this is high potential region and this is low potential region. Now consider that I place a small test charge at high potential region. Let its energy is 25 joule. Now as usual, the charged particle will move from high potential region to low potential region. Now at the low potential region, let the energy of the charge is 5 joule. So the potential difference is 20 joule. Thus it is the potential difference due to which this charged particle moves from one region to another region. Therefore, it is universal fact that an electric field, charged particles also move from high potential region to low potential region in order to lower their energy. Now as we learned in the previous example that this ball experiences air resistance while moving from high potential region to low potential region. Similarly, this charged particle also experiences resistance when it moves from high potential region to low potential region. Now listen carefully. We all know that current is nothing but the net flow of charges per unit time. Here, when this charged particle moves from high potential region to low potential region, we say that current is produced. Let me repeat it. When this charged particle moves from high potential region to low potential region, we say that current is produced. Now if I ask you, what is producing this current? Pause the video and think about it. Well, the answer is simple. It is potential difference that is producing the current. Let me repeat it. It is potential difference that is producing the current. Remember that no potential difference means no current. Thus note it down that potential difference always produces electric current. Now using this fact, Ohm's Baba states that current is directly proportional to the potential difference. Secondly, Ohm's Baba states that current is inversely proportional to the resistance. When we combine these two equations, we get I is equal to V upon R or V is equal to I into R. Personally, I say very important res. Therefore, we define Ohm's law as current flowing through a metallic conductor is directly proportional to the potential difference at constant physical state. By physical state, we mean constant length, cross-sectional area, resistance and temperature. If we change length, cross-sectional area and temperature, current is no longer proportional to potential difference. Here, let me teach you one important question. How can we generate potential difference in electric circuit? Well, using cell or battery, we can easily generate potential difference. For example, this battery can generate 1.5 volt potential difference, This battery can generate 4 volt potential difference, and this battery can generate 8 volt potential difference. Also remember that this battery can produce maximum current because it has maximum potential difference, while this battery can produce minimum current because it has minimum potential difference. So note it down all these important points. Now let me explain Ohm's law by real life example. For example, consider this electric circuit. Here, let the potential difference of the battery is 1.5 volt. We use the bulb as a resistor and its resistance is 3 ohm. When we switch on the circuit, we will observe that 0.5 ampere current pass through the circuit. Now I am going to use 2 batteries having 3 volt potential difference. I mean, I double the potential difference. But I keep the resistance of resistor as 3 ohm. When I switch on the circuit, we will observe that 1 ampere current pass through the circuit. It shows that if we double the potential difference, electric current is doubled. Thus, therefore, we say that current is directly proportional to the applied force and Ohm's law is 100% right. Lastly, let me teach you one of my favorite questions. Which material follow Ohm's law? Well, only metallic conductors and their alloys follow Ohm's law, like silver wire, copper wire, etc. Remember that Ohm's law cannot explain the behavior of current in semiconductor devices, diodes and transistors. Finally, one bonus question. Why filament bulb or LED do not follow Ohm's law? Well, it is because with the passage of time, the temperature of the filament increases, due to which resistance also increases. Hence, the physical conditions no longer remain the same. Therefore, current is not directly proportional to potential difference. So, filament bulb and LED bulb do not follow Ohm's law. I hope that you have learned all about Ohm's law.
Okay, this is a very short video on ohmic versus non-ohmic resistors. Ohmic resistors are any resistors that obey Ohm's law, V equals IR, and any increase in voltage creates a linear increase in the current, so that's pretty straightforward. And if you look at V equals IR and rearrange it so that I is equal to 1 over R times V, you can see that if V is our X value and I is our Y value, 1 over R is taking the place of the slope in that equation. So the slope of this line would be 1 over R, the resistance of that specific resistor. In comparison, non-ohmic resistors are resistors that do not obey Ohm's law. Any increase in voltage creates a non-linear increase in the current, so the resistance of the material changes based on the current moving through it. So in this case, you can see that the more voltage you apply, there's a greater magnitude of current going through, and it's increasing in a non-linear way. So that means that more current is going through and experiencing less of a voltage drop per current than before. So that would actually mean that in this case, the resistance is going down over time. Which makes sense because if the slope at any one point is 1 over R, and the slope is increasing, that means that R must be decreasing as it goes.